Hey everyone, welcome back to my YouTube channel. Today we are going to dive into a real interesting concept called salting in the data processing, especially in big data platform like Spark. Salting is a technique you use to solve a big problem called data skew that can occur when processing large data set. We will explain what salting is, why it is useful, where it can be causes the issue, and most importantly, how it will work with some real world and everyday life example. If you are new here, don't forget to subscribe to the channel and hit the notification bell for more tech and data video. Let's get started. What is salt? Okay, so we know like the data skew. So before we get salting, we need to understand what is the data skew. Imagine you are working with a massive data set, but one part of the data is much larger than other. For example, let's say you have a data for 10 stores or around the 5 stores, whatever the number you can consider, 5 or the 10 stores. And out of that, like suppose take here like the 5 stores. And out of that is 4 store have the normal amount of sales, but one store is a huge chain and has the 80% of the sales data. When this happens, the large store data is unevenly distributed to one worker or the node in your system, while the other worker only have to deal with the small amount of the data. This is the data skew. It creates a imbalance where one worker has to work much harder than other, showing down the entire process. Okay, so we'll understand here like how the saltin will work on the skew data and how the data skew will happen. Okay, so let's start like understand what is salt. So how can we like the uneven distributed data, how can we solve this problem? So how to fix this problem, and that's where salting come in. Okay, salting is a technique where we add a random salt value to key you are using the distributed data. By adding this random value, we artificially break up large chunk of the data and spread in across the multiple worker or the node. For example, instead of having all the sale from that big store go to one worker, we add a random number to the store, like the store ID underscore something like store 001 or 002, whatever, like the so on, like based on our choice. Then there are called a salt key. So the one key we are divided into the five. So that's like called the salt key. So we are explain here before the salting how the sale data looking into the five stores. So store A have the 100 transaction till store D. But store E it is like the 10,000 transactions. So for that store E we'll apply the salting. Okay. So once we apply the salt mechanism, so as we understood, like the one key, we will divide into the five key, store E underscore one, store E underscore two, like that. So we'll divide the key. So once we divided the key, so now we can see how the data is distributed. So 1,000 records, so how we are distributed around the five store, whatever the temporarily salt key we have created, to 2,000 transaction we have distributed here. Okay. So simple real life example. Let's take some simple life real life example. If you are want to take this as our daily life, so I like to explain. Imagine you are at a restaurant with five waiters and a group of 50 people arrive at the same time. Instead of having just a one waiter serve to entire group of 50, you decided to split the group into smaller table of the 10 and assign a different waiter to each table. Now, instead of overhauling the one waiter with all the work, five waiter can handle the job at the same time. This is exactly what salting will do. It split the large workload into the smaller chunks so that it can be processed in the parallel. By multiplying the worker, the random salt help to distribute data more evenly. Okay, how salting work in the data processing? Let's understand how the salting will work in the data processing. Now let's see how salt actually work. Okay, imagine you are joining the two tables in the Spark using the store underscore ID or like whatever the column name, and one store has most of the data. If you don't apply the salting, Spark will send all the data for that store to one partition, causing the imbalance. Okay, but when we salt the data, we add a random value to the stored id. So instead of joining just store id, we can now join store id underscore e. Okay, which spread the data across the multiple partition. After processing is done, we can remove the salt to bring the data back to its original position. Okay, so till now we have understood like the how the data skew will happen, and based on that, how the salting will resolve that problem. So dividing the one id into the multiple partition, s- and how that partition will work. So here I have given the very simple uh, code example. How can we implement while like writing our code in the notebook? Okay, this part notebook. So let's understand. We'll import the function, and after that assume the df is our original data frame. So in that, like we have given the five number of salt partition. Okay, so that five number of salt partition, what we are doing, combining with our ids. So see here, like what we are doing, salted is equal to salted df with the column stored id underscore salted. So this is the one, the id we have given. And after that, what we are doing, concatenate df store id dot elite to salt id. So the whatever the original id we are adding to the alias kind of the thing to other id and processing the data. So this is the way we can like add the salting. Okay, so to process the data, so it's like as I said, it's temporarily we can process. After that, we can bring to the original position this. So let's understand like, is there any advantages, or is there any advantages using the salting for the skew data, or this is only the problem? Because there are a lot of problem, and every problem have their own advantages and disadvantages. So salting has the several important advantages. Okay, fix the data skew. So normally, as we understood here, whenever the data will come, the skew kind of the things, the big benefit for the salting is that it fix the data skew by distributing the data more evenly across the partition. Spark or any big data processing tool can work faster and more efficiently. Okay, this is the where the skew data will come problem. So we'll fix that. So second one is like the improve the performance. Salting makes sure that no single worker or the node is overloaded with the too much data, improving the overall speed of the processing. So it is the performance also, and the scalable for the large data set. When they deal with the very large data set, so salting it will help to distribute the heavier data part into the small chunk, and ensuring that large data scale process can be happen without slowdown. Easy to implement. Salt is relatively easy to implement with the few lines of code, especially in the platform like Apache Spark. Okay. Now the disadvantages. So let's see if there is any disadvantages for the salting, or it is easy. Of course, salting also has some drawback that can be need to be considered. Okay, increase the complexity. Salting, what will do, it will increase the complexity some extent. So introducing more complex into your code, so it will make the code complex. You need to generate the random salt, append them to your key, and then remove then later. This can make your code harder to maintain. Okay, extra processing overall, up to some extent removing the salt, creating the extra processing step, this can increase the processing time slightly. It's not more, but slightly, especially if you are working with a smaller data set where the skew isn't a big issue. Okay, so if you are working the smaller data set, so, and of course like if you are working the small data set, we no need to be like that much, will be like so cautious. Okay, so potential over salting, if you add too many salt key, it might end up with the creating too many partition. Means we have to be sure that how much partition we have to be applied in our scenario. Only five partition we have did. So like this, like we should be sure that so how much partition we are creating, so which can be like taken care very carefully. Okay, else it is a performance issue again, not always be best solution. So salting maybe like some extent it is not the best solution, while salting work well for the data skew in the join operation. Okay, salting work in the join operation, the data skew. There is time when other solution also, like suppose, means what we are trying to say here, like every time we no need to be consider the salt, but there are the other solutions. So based on the what scenario, what process, what condition we have to be process the data, so based on that we have to be used, like repartitioning or optimizing the data pipeline might be the more effective. So sometimes we have to be repartition if needed, or maybe like the data pipeline also we have to be optimized. So these are the way we can be considered. So let's understand if there is any causes for the salting, where salting can be causes or the problem. Okay, salting can sometimes cause problem, especially when it overused. If you add too many random salt, you end up creating too many partition. Each partition need its own resources. So instead of balancing the load, you might end up with the slow down the process with too many overhead. Okay, so as we say, like we have to be understand very carefully, and we have to be write how much salt key we have to be create. So that's the important. For example, if you have already small data set and you apply the salt with the high number of partition, so this system will take more time to handle the extra partition than actual processing of the data. So it's important to careful with how much salt is applied. So definitely, as we said, if the small data, we should not apply so many partition. As the we developer, we know that we'll normally will not do, but just wanted to be bring to your notice. So the partitioning in the salt, so it's based on the data we have to be take care. Okay, the conclusion. So what we discuss here, let's to wrap up, salting is a powerful technique for solving the data skew problem in a large data set by adding the small random value to your key. Okay, and you can split the large chunk of the data, distributed them evenly across the worker or the node. Understand? So salting has its advantages also, like improving the performance, balancing the workload, but also come with some disadvantages also, such as increase the complexity and potential processing overhead. As with most things in the data processing, you'll need to be careful considering when and how to salt can get the best results. Okay, hope you understand the salting. So we'll stop here. Let's catch you to the next video. Thank you.